Right? You with me? So to find so to find an inverse function, you've got to switch x and y. So that's why I'm basically doing part D now. We did A, B, and C last time. Switch x and y, so x will go here. Y will go where x would. Everything else stays put, huh? Just the x and y trade. Remember? We did that a few sections ago, finding inverse functions. I think it's on this test, isn't it, that we're taking next week? So switch x and y, invert x and y, and now take that little equation and solve for y. It's like y is right here yelling, I want to be alone. Get me out of this natural log. Get rid of this plus 6 so that I can be alone. So how do you do that?
Subtract. Wait. Divide by.
Subtract y.
There's a temptation. I'm supposed to be running through roll, but I'm wanting to solve this problem. There's a temptation, a strong temptation, to divide by the natural log. You can't do that because that's not multiplication. That's not times. It's not natural log times y plus 6, even though the parentheses look like it, huh? That's why it's so tempting and so many people do that. You can't do that. Why? Because it's like a function. That's why I'm always doing the toaster talk, because I want you to think of all those things, and by all those things I mean like sine, cosine, tangent, natural log, regular log. They're all functions. So in other words, you should look at that natural log of y plus 6 like it's f of y plus 6. That's kind of what it's like. It's a function. You would never divide by the f, huh? Because that's not multiplication, right? Parentheses don't always mean multiplication. When they're next to a function, they mean plugged into that function, don't they? Plugged into that toaster. So that's not times. You can't just divide off that f. In the same way, you can't just divide off that natural log because it's not multiplied. The y plus 6 is plugged into the toaster. So we can't divide. Important to know you can't divide. So what do you do then? Do you have a different question?
Somewhat related question. I wanted to know what's the difference between log and natural log.
Yeah, good question. I'm going to answer that with this very one. Good question. So how do we get rid of a log? To answer that question, let me ask the question. How do you get rid of a log? If you can't divide it, well, then how do we do it?
Did you plug it in a calculator?
Let me ask you this. If I gave you log base 3 of 2 equal, well, that's not right. Log base 3 of x equals 2 or whatever, and you wanted to solve that equation, how would you got to get the log out of there, right? How would you get rid of that log? What would you do? When you cross off a log, we don't divide. We don't come and go, I'll divide by the log. That's not what we do, because again, that's not multiplication. What do? We have a special rule just for getting rid of logs, don't we?
Is it the E?
Right? Remember, when you lose a log, when you cross off a log, what happens? Base, that's that whole base stays the base thing, and the other two switch, don't they? We have a special rule just for getting rid of logs. It's how we translate in and out of the log language, right? So I cross this off, and then the base, the lowered down number, the 3, stays the base, and the other two switch, don't they? Instead of 3 to the x, it's 3 to the 2, and the x goes over there, and then it's just x is 9. Right? So that's what you really have to remember that. It's going to come up a lot, because you'll be tempted to divide or just not know what to do. So whenever you have a log, and I'll get to what natural log is, but a natural log is a special kind of log, any kind of log, when you need to get rid of it, and we do here, we're thinking, I need to get rid of that thing. It's bugging me. I need to get y alone. Y wants rid of it. Well, you can do that. You cross it off, and when you do cross off the log, the base, and that's the trick. We got to find what the base is for that element. The base stays the base. The other two switch. Okay, so then what is the base? I don't see a base. There's not any lower down number here. What is the base for ln? E. Yeah, do you remember from Algebra 2? It's E. Yeah. There's two understood bases. Let me give them to you. If they give you the normal log word, or if they give you the ln, they both have understood bases. The normal log word, it's 10. The ln, it's E. So because every log has a base. So if they're not showing their base, for regular log it's 10, for ln it's E. Yeah. So put that in there. You lose the log, the natural log, same thing, whatever. And what happens then? The base stays the base, so that E, which is the lower down, will continue to be the lower down. And the other two switch. What do I mean other two? Meaning everything else. The whole y plus 6 and the x will switch positions. Instead of e to the y plus 6, it'll be e to the x, and the y plus 6 will go over there. And we got rid of the log. And now it's cake. Get y alone? Sure. Just subtract 6 from both sides. So y equals e to the x minus 6. That's the inverse function. I just did the inverse. The inverse is e to the x minus 6. Notice the inverse of natural log is an exponential. And that's what we were expecting, huh? Exponentials are the inverses of natural logs. Is that good? Remember that? How that works? Does that make sense? So now, while I do roll, go ahead and graph that thing. So the last thing they'll ask you is, can you now graph that e to the x minus 6 thing? Now, we learned how to do that in the previous section's homework. Graph an exponential. So give that a try. I'll run through roll. Nick, Aragon, not here. Mallory is here. That's right. And Ian is here. And Karen is here. And Erica, that's right. And Celine. Celine is here. Okay. And Accra is here. And Lizette. Lizette. And Joel is here. And Alexis. And Vanessa, that's right. And Josue is here. And Lily Flores. No? And Kylie is here. And Adeline is here. And Justine is here. And Vanessa Gernick is here. And Michael is here. And Ian Gerard is here. And Mercedes Gonzalez is here. And Ricardo Gonzalez is here. And Luis Gonzalez is here. And Alexandria Graves, that's right. And Tanvir is here. And Sky. And Pablo is here. Barbara Lee is here. Kevin Lee, no. And Cyrus Martinez is here. And Trey is here. And Ariana Ojeda is not. And let's pick it up. So we want to graph now e to the x minus 6. That's one of the last things they'll ask us. What, number 17? So now graph y equals e to the x minus 6. So how do you graph that? So we learned a times b, no, what did we learn? A times b to the x plus c. How to graph an exponential in general. How do you graph an exponential in general? This is the horizontal asymptote, right? Whatever number is added off there to the right is the horizontal asymptote. So that would be the negative 6, huh? So remember, the exponential graphs always have a horizontal dotted line, and log graphs have a vertical dotted line. Did you catch that from last time? So they're inverses of each other. So horizontal asymptote at negative 6, so 1, 2, 3, 4, 5, 6. Down here at negative 6. Down there at negative 6. Horizontal asymptote, okay. And then the a, the number in the front, that's just a 1, huh? Is the amount that it's jumped up from the horizontal line. So that'd be at negative 5, right? That's the jump above the horizontal line. Remember the details of how this works, how graphing these works? And then, now, normally, pretty much all of our graphs, they go up to the right. The exponential, even the logs go up to the right. I can't think of anything that we have that doesn't normally, unless it's been flipped, go up to the right, huh? So the normal state of pretty much all of our graphs is they climb up to the right, unless they've been flipped. Is there any kind of flipping going on? Is there a negative in front of the x? No. Is there a negative in front of the whole thing? No. So there's no negative numbers multiplying anything. So there's no flips. So it'll just go up to the right like normal on that. So this, again, this horizontal is at negative 6. This dot here is at negative 5. And there we go. Comes down for a landing on this side and goes up real fast this side. Concave up. Remember we talked about concavity last time a little bit, didn't we? Bowl turned up, right? Where's the log graph? And what was the log graph? Well, anyway, we'll do log graph was right here. See how they're inverses? See if I put that blue one on the graph. you'd see that it's like this. See how they perfectly diagonally reflect, they reflect across the diagonal line. They're mirror images across the diagonal line. That black one, maybe you don't know what I'm doing. That black one is the original function, the original question that we found right here, which was, which was ln of x plus 6. So this was ln of x plus 6. This was the original function, and this red one is the inverse function, which is e to the x minus 6. So exponentials are inverses of logs. Their graphs are reflections across the diagonal line. We see all that right there. They're going to ask you domain and range of things too. You can get all that really easily from the pictures, huh? So, and remember they're vice versa. So I would find the domain for each of them, and then the vice versa is the range for the other one. Remember how we learned that earlier? The domain for f is the range for f inverse. The domain for f inverse is the range for f, isn't it? They trade. Remember that? So what would be the domain here? Let me just do the, what's the domain for f inverse, the red one? How far left, how far right? Well, that's negative infinity, positive infinity, isn't it? And that's the domain for f inverse, which means that's also the range for f. And it is. Look at the picture. How far down, how far up does f go? The range for f. Yeah, negative infinity, positive infinity. Now, likewise, let's find the, what is it? The domain for the original function f. There's a vertical right here at negative 6. So what's the domain of the original function f? How far left? Negative 6. How far right? Infinity. Negative 6 to infinity. And that's also the range of f inverse, isn't it? And sure enough, look at f inverse. A low, a bottom of negative 6, a top of infinity. So there's perfect agreement with all that. Do you remember all that? All right. Cover for you. So here's number 18. So f of x, the original function, is negative 6 plus natural x. Can you go ahead and, so they begin by having you graph the original. So basically the next, what is it, 17, 18, 19, 20, 21, 22, 23. So 7 questions. The 7 questions here in the middle of this section are super long and super important. All of them give you an original function, ask you to, either a log or an exponential, ask you to graph it, find the domain and range, find the horizontal vertical asymptote line, then find the inverse function, graph it, domain and range, and that's it, yeah. So basically everything about the original function, everything about the inverse. Super long. They all have like A through F, because there's 3 parts for the original, 3 parts for the inverse. There's 7 of these. I looked it over again. You can tell I solved them all ahead of time. Last week I was looking at it. And, you know, they're really valuable. I don't give you meaningless homework. You know, I looked to see if I could cut any of these out. I can't. They all have a little extra lesson that you really need to learn. So I do a little bit of a talk here just for 30 seconds, because I really want you to succeed. You got to do this homework. That's what it takes to make it through. Really valuable. So let me encourage you. Are you keeping up with the homework? In a math science class, it's absolutely essential. It just is. Not that homework's worth anything, right? Homework in my class was at 50 points. It's nothing, but these become test questions. They absolutely become test questions. And those 7 problems, so for example, if you were to do a good job on this section, I can't imagine it taking less than 3 hours, unless you're a lot smarter than I was when I was a pre-calculus student. A lot of time. Each of these questions, 6 parts, tricky stuff with inverses, and really, but super important. Every one of them is valuable. Everyone has an extra wrinkle about being in the parentheses or being out of the parentheses or reversing. They all have a lesson. They all have a lesson. You skip mastering them to your own lack of knowledge. So let me just encourage you. You know, if you want to go the math science road, if you want to go that way, you have to master the homework. I know GEs. I took them too, where you can just, whatever, study the material, test goes okay. Math science, you have to, we're learning Chinese here basically, right? You can't just skip the verbs because you're not in a verb mood. You will not learn the language, right? So you have to master these. So just please let me appeal for your own good. And the help's available. I know you might say, well, I can't do them. Well, there's help. There is. Roberto's there. Look at all those hours. Any of those hours. Go see him. Come see me 12 to 1. The help is there, but you have to give it time. You have to give it time.
How
Seema.
many of these are going to be on the exam?
Couple, at least. I look at the practice exam. It'll be just like the practice exam. Practice exam's all available. You guys know where that is, right? I got some good questions about where that is. I hope I'm being clear. It's not on Canvas. I don't use Canvas at all. I don't know if that's been clear. It's all on Math Excel. First page of Math Excel, right at the top, under announcements. Both the first practice exam. Who cares about that now? Second practice exam is there. Yeah, we'll go over it next week, but it's already there for you to look at this weekend. Good question. All right. So let's do it. I hope you're doing. I hope you did all the homework in 5.3. Not for points. Who cares about the points? But to learn them for the test. So how do we do this? How do we graph? So let's go to it. What does that -6 do? Let me write again because I know we've only done it one day and we haven't done the homework on this yet. So let me be faithful to help you. It's we learned that log base b of what is it, x plus c. We learned how to graph that in general, right? And the plus c is the vertical asymptote, but it's opposite because it's in x, right? So negative c is the vertical asymptote. Remember that? So you want to have those rules down and the exponential rules. And they're similar but subtle differences. It just takes time. It takes lots of working, thinking, getting it down. So so it's in the parentheses. Now, is this -6 in the parentheses? No. He's not an x effector then. You with me on that? That -6 is not an x effector. Well, what is in the parentheses with x? Nothing. 0. So what does that 0 mean? No, there's a vertical. It's at 0. It's at 0. There's always a vertical. Every log has a vertical, and every exponential has a horizontal. So it's just at 0. It's just plus 0 there. So you just put it right, the vertical is right there at 0. So whatever's in the parentheses, or there's no parentheses here, what in x's little world, remember that's an x effector, huh? Like we've learned all along. And the -6, well then what's he? He's not in x's world, so what is he? He's a y effector. He's a down 6, isn't he? He's just going to move the graph down 6. Okay, so we got the dotted line. There's no negatives. You know, the normal log goes up to the right. Concave down though, but still up to the right, huh? Goes up forever, down forever. It takes a dive at the vertical. You know that all the graphs go up to the right unless they've been flipped. Has this one been flipped in any way? Is there a negative right on the natural log or right on the x? No. There's no negatives. There's no flipping. He'll do the normal up to the right kind of thing. And where does he always do that? I don't know if I made it very clear, but he always does it 1 unit to the right. 1 unit to the right of the vertical. That's what the exponentials normally do too, right? Have we seen that? It's A, but A is normal like it is here. See, it was 1. That's normal, right? It's not, and those always hit 1 unit above the dotted. Same thing for logs. They hit 1 unit to the right of their vertical. But what's the -6 going to do? Move that down 6. So it'll go 1, 2, 3, 4, 5, 6. So in reality, that over 1 thing will happen at down 6. So it'll be right there. It'll be over 1, down 6. But it's still the same thing. You know, it's still vertical here. It's still going to take a dive and it's still going to go up to the right forever. It's just been moved down 6. So there it is. There's the graph of -6 plus natural log x. That makes sense? It's got that dot, and that's not it. What's that? Oh, that's the inverse. Okay, I'm thinking that's not it. I'm off the screen there. Yeah, I need to roll that up. Anyway, so that's the graph of natural log, -6 plus natural log x. We okay with that? If you're, again, natural log is just log base e. I don't care about the e. I don't need to do anything special with it. Good for there? All right, let's find the inverse function. They'll ask you domain and range. You can do all that easy, right? That okay on that? Well, maybe I should do it real quick. What is the domain of this function? How far left? How far right? 0 to infinity. We good on that? What's the range on that thing? Bless you. Range is? Goes down forever. Up forever. Negative infinity to positive infinity. Remember, they go up forever. Even though logs do it real slow, they're slow growth, they're concave down. They're like a bowl turned down, aren't they? So they're slow growth, bowl turned down, but they do go up forever. So, but just slowly, right? Exponentials are bowls turned up, aren't they? They climb fast, concave up. They rocket up. Okay, so now, can you find the inverse function? Let me let you do that. So there's the original function and his graph. That's what they'll ask you in the first couple questions. Now, and they ask you for the vertical. There it is up there. X equals 0, like we said. There's the vertical. X equals 0. We knew that right in the middle. Now, find the inverse function. Just try that on your own. You get more out of it than if I just whip it out. So go back over here. So f of x equals negative 6 plus natural log of x. So find the inverse. So how do you find an inverse? These 7 problems are such painful problems, but really good because they make you review inverse functions, they make you review domain and range, they make you review the log rules, the exponential rules, the graphing rules. They make you review so much stuff. They're so good for you, but they're good for you like in a painful way, like exercise is good for you, right? So it's mental math exercise, but you got to do it if you want to master this stuff. So, all right, so this is y. So how do we find the inverse function? We switch x and y. Invert. Invert. X and y. So the x and the y trade. The x goes here. The y goes there. Like that. That good. Switch x and y. And then step 2, solve for y. How do you solve for y? Let's jump the negative 6 to the other side. We good to there? Y is saying, I want to be alone. Get me alone. Right? So go ahead and get y alone. So how do we get that y alone? Can I divide by the natural log?
We switch y with.
Good. Yeah, hope you know that whenever we're trying to get ln alone, get a log to lose a log, that's the base stays the base. Other two switch, don't they? The base stays the base. The other two switch. So, well, what base? I don't see a base. I don't see a lower down number anywhere. So you know it's e, huh? For ln t. For regular log, it's 10. For ln, it's e. Cross off ln. The base stays the base, meaning the e, the lower down number, continues to be the lower down number. And the other two switch. Well, what other two? Meaning everything else. The whole x plus 6 and the whole y trade spot. So the y goes over here. Instead of e to the y, it's e to the x plus 6, and the y goes to the other side. And there we go. That's the inverse function. E to the x plus 6. Now, last step, can we graph that thing? So go ahead and graph e to the x plus 6 real quick. And that's going to use your exponential graphing knowledge. Okay, so how do we do that? Well, we have, again, the a times b to the x plus c. The c is the horizontal, right? Exponential graphs always have a horizontal dotted line. The log graphs have the vertical, huh? So we're looking for a horizontal. There's always a horizontal. It's whatever number is added off to the right. What's added off to the right? Well, just 0, huh? So the horizontal is 0. So right here. No surprise, the log's vertical was 0. It's going to be the same place, isn't it? Except it's horizontal instead of vertical. Okay, the a in the front is just 1, like it usually is, which means 1 unit above is where the center dot is. And is there any negatives on any x or in the front? No, there's no flips. So that means it'll just go up to the right like they normally do. It's not been flipped anywhere funny. Except, what's that plus 6 going to do? Yeah, left 6, huh? Because x is always opposite. So that's in x's little world, isn't it? If it was like this, if the plus 6 was on the base level, like that, then that 6 would be a vertical up 6, wouldn't it? That would be a y effector, because it's not in x's little world. That'd be an up 6. But if it's up, since this one is in x's little world, it's a right-left thing. Opposite, it's left 6. So what does that mean? I need to take this center dot, and instead of being, at the center, it's going to be left 6. So it's right over here. It's going to be left 6 up. It's still up 1, but it's left 6. And there we go. Comes down for a landing to the left, goes rockets up to the right, negative 6, 1. See how it's a reflection? If I went back and said, what was this? See how this graph here in blue? Right? See that one? If I put that back If I put that back, so that graph right there, that blue, that was the original function, the natural log, whatever it is. Now, negative 6 plus natural log x. That one's right here, like that. That's the original function, negative 6 plus natural log x. And the red one is the inverse function, which is e to the x plus 6 power. And see how they are indeed a reflection right across the diagonal line, aren't they? Functions and their inverses. And you can answer all the domain and range questions, right? Is that okay on that? So that's just number 1 and 2. They get harder. I wish I had time. I got to jump ahead to number 3, the last one, the hardest one, if time allows. But I got to first cover 23 for you. So log base 5 of x equals 3. So they change gears here at number 24. This will be a lot easier. This will be quick. So how do you solve for x there? X is saying I want to be alone. Get this log thing off of me. Get rid of this 5 so I can be alone. So how do we do that? How do we get rid of that log? Yeah. We can't divide by it. We have a special thing for when we get rid of logs. Base stays a base, other two switch. So the lower down number continues to be the lower down number. Base stays a base, other two switch. Instead of 5 to the x, it's 5 to the 3. X is over there. There it is. 5 times 5 times 5. Use your calculator. 125. And we got it. Easy. Move on. Okay. So log base 2. 5x plus 6 is 2. Same thing. Solve for x there. Cross off that log. Cross off that log. Lose the log. Base stays base. Other two switch. Cross off the log. Base stays base. Other two switch. Instead of 2 to the 5x plus 6 is 2 to the 2, and the 5x plus 6 goes the other side. That good. 2 to the 2 is 4. Now how do we finish solving for x? Subtract 6. Minus 2 is 5x. Last step, divide by 5. Bless you. Are we good? There it is. All right, so you know how to handle log. Okay, so 27. ln e to the x is 8. Okay, so the trick on, same thing when I cross off the log, base is base, other two switch. But one of the tricks on this one is notice that that e is not the base. There's another invisible e that's the base. How do I know? Because that e's not lowered down. Right, the base is lower down, or it's invisible. So really there's another e there that's invisibly the base. How do I know? Because this e is not the base. The black e is not the base because it's not lowered down. Bases are on the bottom. That's what a base is, right? So you got to put another e in there because ln, remember ln always has a lower down e, like regular log always has a lower down 10, huh? If nothing else is showing. If there's no other lower down number showing, that's what they have. Okay, so what does that mean? Well, then the rest is regular. Once you realize that, it's pretty easy. What do? Lose the log. Any log, natural log, regular log, whatever, same rule. Lose the log. What happens? Base stays the base, so that blue e will stay as the base. Base stays the base. And the other two switch. What do I mean the other two? Everything else. That whole e to the x and the 8. Everything other than the blue base e. Switch. Instead of e to the x, because that looks like e to the x. It's made to look that way. Instead of that, it's e to the 8, and the e to the x goes to the other side. So yeah, that one.
Easy.
Yeah, x is 8, clearly. We're done. Good there? That okay? You just got to stick in that other invisible e. And then it's the same rule. So really from the beginning, now there's a little lesson in that problem. You're right. From the beginning, therefore, here was the original question. We could have said, so really ln's and x's, no, ln's and e's are opposites and they cancel each other out. And it's just x is 8. That's true. We're going to use that in a minute. ln and e are 1. You can do them on your calculator. They just cancel each other out. They're opposites. Because ln is base e. So ln base e of e just cancels out. We see it. We see it here. It happened, right? That proves it's so. So log base 3 of 9 is 3x plus 1. Okay, so try that one, same kind of thing. Lose the log, base stays the base, other two switch. Do that, see if you can solve for x there. So lose the log, base stays the base. Other two switch. Instead of 3 to the 9, in these cases switch, it's 3 to the 3x plus 1, and the 9 goes over there. Good so far. Now, how do we solve that? You make bases the same. Yeah, remember that? Make the bases the same. Good job, good memory. 9 is 3 squared, huh? Yeah, if you make the bases the same, then the powers have to be equal, because if 3 to something equals 3 to something, those somethings must be equal. So that means 3x plus 1 must be 2. Now we can solve it. Subtract 1, 3x is what? 1. Divide by 3, 1/3. Good? That okay? All right, there are about a few of these, and then go back and at least do number 23, that last graphing one. So e to the 4x is 6. Okay, so this one's hard. How are you going to solve for x? First off, before I dive into the how you do it, you see that nothing we've done so far will do it. We need something new. Does everybody see that? We have no way of, how are you going to solve for x? It's climbed into the power zone up there. And you think, well, yeah, we just did a power one here. Yeah, we did, because we were able to make both bases the same. See, that's what we normally have done with powers, huh? Is you make the bases the same. When something climbs into power, the way you handle it is you make the bases the same. But you can't do that here. How do you make e and 6 the same base? You can't. There's no way to do that. We need a new technique. And by the way, that other technique was kind of gimmicky anyway. I mean, like, what if just instead of 9, this had been 8? How do you make 8 3 to something? You don't. So you see, that was kind of a gimmicky plan we were using for a while. Real life, they build bridges and do stuff with math. You can't solve things that way. They were just making a few nice problems where the bases could be made the same for a while. But now it's, all right, time for real life. You can't always make the bases the same. So what do you do when the bases cannot be made the same? You take the ln of both sides. So let me write that. So solving for x in the power zone. So I know you get so much math, and we're always dumping so much math on you so fast. You're trying to remember it all. So something has to happen in your mind so that you remember this really long term. Because it's one of these things that will just pop up out of the blue in the middle of many other things. And you got to remember, oh yeah, x has climbed into power. X has climbed into power. We got to get it out of power. We got to dethrone it, right? We got to get it out of the power zone. So step 1 is you try to make the bases the same. That's what we normally do, right? And we'll have some of that on the next test, because we had that, last week or week before, wherever it was. We did a bunch of that, and there'll be a few of those on the test. Try to make the bases the same. But if you cannot, there's one special thing that dethrones it, that takes it down. If you cannot, then ln both sides. Logs have this great quality of pulling down powers. That's what we need, right? Because do you see the problem? Like, how are we going to solve for that 4x? You got to get it out of the power. You can't divide by it, right? I can't go divide by 4x. It's not e times 4x. It's e to the 4x. See the problem? The problem is it's in the power zone, right? Let me 30 seconds. Here I am again. I'm a wannabe history teacher, but I got to do something. The reason I really do have a math purpose in this, because what I notice is this comes up later. Like, people will do good right now. You'll follow me, and I'll give you 2 of them in a row, and you'll nail them, no problem. Then all of a sudden it'll come up in some other graphing thing, and everybody will freeze like the deer in the headlights. Like, what do we do here? I'll go, well, what do we do? But that shows me they don't really have it long term. They don't really just know when X is in power. So I'm always listening to Churchill's biography. So I'm always thinking about Hitler and Stalin and that whole thing. Stalin was way worse than Hitler. Anyway, how did Hitler get into power? We're talking about power. So dethroning powers. How did Hitler get into power?
He got elected.
Yeah, that's the funny thing. He didn't. He did not get elected. What's that?
Propaganda.
Yes, yeah. Yeah, he lost the national election, lost it pretty badly, was put chancellor under the president, and then, I didn't know what the name of it was, what's it called?
Weimar Republic?
Okay, because the fear of the communist stuff, right, which a lot of people rumor was the Nazis doing their
They
thing.
canceled the constitutional
Yeah.
procedures.
Yeah, that's what happened. So I just think it's very interesting. So Hitler got into power. He was not elected. He lost the election pretty badly, but he was appointed second in command or whatever, was chancellor at that point. Chancellor was a nobody. Well, not a nobody, but way less than the president. And then there was the fear of the communists. Rumor is it was the Nazi party themselves blowing up things around Germany to scare all the people. And then they said, "Oh no, we gotta have military, whatever you call it, military rule of society. We better give the chancellor special power." And that chancellor never lost that power. Well, he died, so he lost that power, but not till that point. All right. So anyway, Valkyrie, I love that movie. Very interesting about one of the many attempts to take Hitler out of power. Enough history. I hope you remember. We got to get that thing out of power. So when you look at that, I hope you remember my little goofy history stories. Get that thing out of power. The whole thing is when X is in power, we got to get it out of power. So I hope you just remember it long term that way. X in power. When the wrong person gets into power, that's a big problem. When X gets into power, that's a big problem. What'll do it? ln of both sides. So let's do the ln of both sides. Okay, now there's this great quality of, there's nothing else we have in the math curriculum that dethrones powers, that pulls them out of the power zone. 4x, boom, down it goes. That's it. Now, really, we're going to cover that in the next section. I'm kind of dipping into 5.5. We'll talk about that property, but I think it's the best way to go right now, just to give it to you right now. There's another way, but this is the way we're going to be doing it again and again and again in the future. So let's just get on that one track. I think it'll be easier for y'all. So that 4x just comes down. You see, that's a special quality we haven't seen before. It's in 5.5. We'll do a bunch of it, but there it is. Powers come down to the front. So let me, if you can, L in both sides, let me write it for you. Power down to the front, and also ln of e is just 1. Remember how we noticed that earlier, so that'll help too. ln of e is just 1. So that ln of e there is just 1. So you see, that's the big deal. Nothing else pulls powers down to the front like that, except logs. So then, now it's easy, huh? Now that 4x isn't in power anymore, they could have just got Hitler out of power, or Stalin, even better. But God took him out of power. ln 6/4. And there we go. Good. So there's x. We're done. We solved it. They want the exact answers. They just want you to leave it just like that, no decimal.
So
Yeah.
ln is always just 1?
Yeah. Good question. Exactly right.
Or is that something different?
What's that?
Would log e be 1?
No. Yeah. Good question, Cyrus. No. Log e would be something a little different. Yeah. Just ln. And the reason ln e is 1 is because he has a base of e as well. So those e's kind of like cancel.
If
And this
you
one is.
log 10, it would be 1.
Yeah, log 10 would be 1, because log also has a base 10, so that would be 1. You're right. Okay, let's try another one of these. Make sure. Okay, so e to the 2x plus 9 equals 11. Okay, so I hope you see it. You remember all my history stories. X is in power. It's in power. So we'll get it out of power is ln. So take ln to both sides. ln of both sides. And then that whole power, that whole 2x plus 9 now drops down, right? Logs are the only thing we have in the math curriculum that dethrones powers. That's kind of a real special. I want you to see it's special that powers come down to the base level. That's really special. That's really weird. And that's really what we need. So that whole 2x plus 9 comes down from the power. It's dethroned. It's out of power right now. It has no more power. And ln e, that's just 1. Good to there. So then 2x plus 9 is ln 11. Now let me help you here. There's an easy mistake to make. When we finish solving, subtract the 9, you know. That 9 can't go in there with the 11 because that 11's really plugged into the toaster, you know. The 9's outside, so watch out for that. So just the 9, you don't have to put parentheses, but just keep that 9 separate. Just know that it's outside the log. Separate, divide by the 2. And there we go. They want exact answers. They want you like that. They don't want a decimal. Type it in just like that. That good? That all making sense? X in power, get it out of power with a log. All right. Okay, so 5 times e to the 0.5x equals 7. Okay, so I should really say, I should add one more step to the puzzle. Get the base alone first. Get the base alone, then ln both sides. Yeah, so your first step here will be to divide by the 5, you know what I mean? You got to get that e thing alone. You always got to get the base alone before you do the ln thing. So I want you to catch that lesson. So divide by the 5 on both sides. Now ln both sides. Now ln both sides. That good on both sides? ln both sides like that? That's what so x in power, you just want to remember deep, x in power, ln both sides. The only thing we have that pulls powers down is the log. Okay, so then 0.5x, ln e is ln 7/5. That's ln e is just 1, that's just gonzo. So how do we finish getting, now that x is out of power, it's not a problem, right? It's pretty easy. How do we finish getting x alone? Just divide by the 0.5. Boom.
You have to clear that because it's a fraction of a fraction.
I think they'll let you just type it in just like that.
Are you sure?
I'm not sure.
You told me that once about
Did I?
one rule, and then you had it wrong.
Yeah, I'm
Can
pretty
you
sure.
Plug it in just to make sure.
No, I don't got time. And at least start it, that hardest graphing one. Maybe find the inverse with you. Okay, so these word problems, you don't really need to pay attention to all those words. It sounds funny to say, but you don't. All you really need to know is what the two variables are. That's really all that matters. So p equals 760 e to the minus, 0.145 h. Yeah, all you need to say is, hey, what's p? Where is it? Pressure. P is pressure. And h, it's off the screen, but it's height. It's off the screen. So that's all you need, because then when they ask you a question, like they say in part A, pressure 381. Oh, so they're saying P is 381. So that means you just stick 381 in there for P and solve for H. And they want to know the height. They want to know the height when you do that. So that means take the equation, put 381 in the P slot, and solve that equation for H. Does that make sense how I got to here? Now, that's easier said than done, huh? How are we going to solve for that H?
Divide by 7/6.
Yeah, it's in power, huh? It's climbed into power. So you go, oh yeah, got to get it alone and log both sides. Here it is again. So divide by the 760. And when you divide this right here on your calculator, it's some really ugly decimal. And so I would just leave it, guys and gals. I think it's easier than having some big, long, ugly decimal. If it was clean, if it was like 0.3 or something, yeah, I would just write that. But if it's so long and ugly decimal, I'm just going to leave it. And 4.5, oops, getting kind of sloppy here. 4.5h. And, okay, now, so I got the base alone. There's the base. I got him alone. And now what am I going to do? ln, huh? Because h is in power. Whenever you get the thing in power, that's what brings it down. Can I go dot, dot, dot? I want to look back at the graphing then. So just get that alone and divide. And now, last minute or two here. Okay, so they give me f of x equals e to the x minus 3 plus 2. Okay, well, they're going to ask me to graph it, and then, yeah, well, can we graph it first off? How about that? Let's graph it. Remember, a times b to the x plus c, plus c. So can we graph it? Okay, so what's that 2? That's the horizontal dotted line at up 2, huh? That's the horizontal asymptote. Exactly right, at up 2. 1, 2. Up at 2. So there's the horizontal asymptote. Good. Okay, what's the A? Yeah, it's like usual, it's 1, huh? Which means 1 unit above the horizontal is the center point. And now what about and there's no negative multiplier, there's no flips, right? So it's just going to go up to the right. What about the minus 3, though? What will the x minus 3?
The right.
Good, because x is always opposite, huh? So go right through. So that center dot won't be at the center. It'll be 1, 2, 3 to the right. Be right there. All right, that good? And then it'll just go through that dot and up, and away, and come down for landing on the other side. That good for the original? You can answer domain and range questions from there. And then inverse function. Let me just do it. We're running out of time, aren't we? I'll just do it real quick for you. Switch the x over here, the y right there. How do you solve that for y? Move the 2 over. What am I going to do at this point? I want to show you this one last thing. How do you solve for y? Good. You remember, because again, y is in power. That's why I tried to sync it long term. All of a sudden, here it is again. Whenever the thing you want's in power, L in both sides.
Then there's an X and then there's a Y.
Yeah, L in this side, L in that side. The whole y minus 3 comes down. L in E, that's just 1. L in x minus 2. And now just add the 3 over. So L in x minus 2 plus 3 is y. That's the inverse function. Does that make sense? So whenever the thing you want's in power, L in both sides, right? All right, guys, that's even more than the time we had, huh? All right, so this will be due on Monday. It's already on the board. Have a good weekend. Do a good